It's great to be here to talk about my favorite thing, which is how to do science in a way that is as painless as possible. So at this point, I hope everybody has had a chance to watch the introductory video. So if you haven't, frankly, your time would be better spent just to go watch it and then find the recording of this later, because I'm going to assume that you've already watched it. So the link is there at the bottom. So in the watch before you arrive part of the talk, I run through a bunch of things. So I gave you an introduction to how to set up a machine to use R. I talked a little bit about why bother with reproducible research workflows. I went over the idea of what data scientists are doing now to have fully reproducible workflows versus what problem solvers and researchers can realistically try and accomplish. I also introduced everybody to the RUM package, so R for the University of Miami, or R from your friends at the University of Miami. I worked through the basics of using R Markdown. So it's a structure of a document. And so I talked about how it has a header where you put details for how the report will be rendered. And then there's a body which contains both text and code. I made the point that R can be knit, R Markdown can be knit to make lots of different kinds of pretty reports. And then I went through using RStudio as a word processor, basically. So how you can set up reports that are, as easy as using Word, if not more. And I introduced how modern RStudio makes it pretty easy to put in cross-references. I showed how you can use inline calculations and code blocks for doing analyses. I showed you how you can use references or how you can create references and citations and change the style references. And then I talked about Git and GitHub, and I talked about the .gitignore file, which is a list of files and file types and folders that Git should ignore. I tried to stress how important it is to get a copy of this in place because it will prevent you from accidentally leaking data with the world and getting sued. So the key point is you always want to have a gitignore file in every Git project folder. I talked about the workflow of using Git, which is you save your work, you say that you want to take a snapshot of a file, you leave a description of the snapshot, and then you take the snapshot. And then I went through the GitHub workflow where you can make a repository and then sync your snapshots with GitHub. So that was an intense 35 minutes. I've gotten some feedback and I've gotten some questions. So let me hit the questions I've gotten so far. So they were, where should I store my Git enabled projects? So, whoops, there's an extra period there. So I have a folder called GitHub in my documents folder. And so I put all of my GitHub related projects in that one folder. You can put it anywhere you want. However, you need to be very careful with Git enabled projects that are living on Box. So if you are the only person who's using the folder and you're using Box Drive or Box Sync, it will be great. But as soon as you start to share that folder with someone else, expect things to go horribly wrong. So the moral of the story is keep your Git enabled projects either on your local machine or use Box or Box Drive or Box Sync, but don't share that folder with other people. What happens is Git gets confused about who is currently working on it if two people log in at the same time. So it's one of the biggest gotchas I know. I also got a bunch of questions about how does the gitignore file work and like, why is it such a big deal? Again, the key thing is it keeps track of files that should not be shared outside of the university. So the gitignore file that I offered you guys, it has a list of files and file types and directories that Git should not back up. So you want to have a gitignore file in each of the Git enabled project folders. You can put it in a subfolder if you want, but it's weird to do that. Most people just put a single .gitignore at the top of every file structure. Okay. The last question, which was really a great one, is if I'm going to use GitHub, how do I set up so that I can permanently sync my password so I don't have to keep typing my password? Well, the moral on that is Git doesn't want you to have a permanent password, just like University of Miami wants you to cycle the password. But let me show you the process of setting up a permanent or a last a while password. So again, Git strongly recommends that you change your password regularly. So the secret for doing this easily is you want to run these 4 lines of code. So you can paste this into the console and this will load in a couple packages. So in the introductory tutorial, I showed you how you can add rum onto your instance of R. This is the same magic as installing rum. So this will install the use this package and the git creds packages. So you run this one time and these are available till you reinstall R. Then you can run a command which will create a GitHub token. So out on GitHub, it will make a password out there and then you'll pull it in. Okay, so these 4 lines, here this is in practice. So after you've installed those 2 packages in the console, you would just type use this : create GitHub token. It gives you a bunch of feedback and you go, uh-oh. It also opens up a new tab in your browser and it has pre-configured all of the options you need for your password. So for your password to work. So you get this window, type a note up here describing which password this is. So you'll notice here that there's different expiration periods. Frankly, I run mine every 90 days because it's the longest recommended time period. So here I give it a name. So this was a September 2021 key, which will work from my workstation. I have a separate one which will work for my laptop, but you don't have to do that. So this is the name of it, and then an expiration period, and then you click generate token.
All the bin style firewall containers, they need to.
Thank you for the mute. So it will create the detailed key, and then you click generate token. And so this window appears. There's a crazy password here. You can click the clipboard here and it will copy this monster. Then back in the console, you say load the git creds package, and then paste in this command from 2 slides back. It'll give you a place where you paste in the password and you're set. So once that's done, GitHub will be synced to your machine and you'll be able to push and pull files back and forth without having to type your passwords over and over again. All right, so there you go. That's 35 minutes plus 5 minutes that are kind of intense. Somebody ask me questions. So are there questions, comments, or complaints before I get going? Can you put those lines of code in the chat? Yes. I can. 1 second while I find this. This one. So there's the 4 lines in the chat as well. And I'll be publishing the slides soon as well. The slides, I'll make them available like the slides that were available for the pre-recorded talk. I'll put them out on Netlify someplace. That's it. Really, it's either so clear or so horrible. Really, going once, going twice. Okay, I don't see anything else in chat. So let me tell you what you came here for. Start talking about what you came here for is the application of this stuff to HIV research. So I showed you the magic for setting up a machine and like some of the tricks, but I suspect that at this point you're like, I see lots of trees, show me the forest. So what I'd like to do is show you the code and the workflow for 2 projects that I'm working on with Audrey Harkness. So the first one is looking at antiretroviral therapy, ART or PrEP, So those are medications used to keep HIV in check or to prevent you from developing HIV in the first place. So the question here is, can we identify profiles of people who will or will not take their medications? And so there's ART and there's PrEP. So that's before exposure to HIV or after being infected with HIV, two different medications. There's a big question about, are the same motivational factors in play in both groups of people? So can we identify groups of people that will or will not be adherent or compliant, depending on your choice words? And are the same factors involved both pre and post exposure to HIV? So that's one paper. Another one, and this is kind of in the formative stages. I'm still developing it, or we're still developing it. And the second issue, or the second paper, is factors associated with Latino sexual minority men's likelihood motivation to obtain a COVID vaccine. So similar to this, we're interested in saying, can we predict who will or will not, but in this case, will they or will they not get vaccinated? And again, can we find profiles of people who will or will not get vaccinated? So one of these is submitted and the other one I hope will be submitted next week. So let me show you what it's like in my world and to work with Ray on research projects. So let me start out with, I think I'll start out with the adherence one. Oops. So in the 35-minute intro, you saw me working with R and RStudio. So this is what my workflow actually looks like. So this is an early stage, or this is a not completed project. What's that mean? At this point, I'm focusing on the code and trying to get this thing right. And so then I can share the results with Audrey and she can tell me whether or not I'm doing the right stuff. So I'm focused more on the code here. Because I'm focused on the code more than the writing of the paper, I start out in like the traditional R mode. I have not clicked the button to switch to the visual editor. So as you recall from the tutorial, if you turn on the visual editor, this looks a lot nicer and you get tools for like bolding and italicizing. But I'm interested at this point in the code. This will look pretty different than what was in the tutorial, the introductory video, because all of the code blocks, or almost all the code blocks there, all of the code blocks have been collapsed. So this is how I normally work. I pull up a project, I smush everything down to hide all of the details, and then I expand out the sections that I'm working on. How do I do that? If you come up here to the edit menu, you can go to folding and you can do collapse all or expand all. And don't worry, I've got all of this in slides. I just want to give you the big picture first, and then I'll walk you through the slides that show you all the gory details. But again, big picture, R Markdown documents, they start out with a header saying what you're going to make. And so this says that I'm going to be making an HTML document. So it's going to be a web page. The web page is going to include a table of contents, and it's going to have that table of contents float. Let me show you what this looks like. So to make a project, you just click knit. Or I should say, to make a document, you push knit. And it thinks for a while. And as it's thinking, I can show you some of the code blocks. So this is just generic setup. This is saying load some packages. Okay. And then it builds the document. So I mentioned this is a web page. I asked for a table of contents. And so this is like the view as I'm working with Audrey. What does she need to see? She does not need to see that setup code block I showed you for a second. She does not need to see the loading of packages. It's just like, she doesn't care. But what she does care about is how I'm processing the data. So this first code, so up here, it's the header appears here. This is showing like my workflow. This is a dialect of R called tidyverse. And I think it's pretty reasonable once you learn a couple a couple details. So you can like read, this is a comment saying I'm residency filtering. So I start out with a data set that has a whole lot of people. For this project, we want to limit to the people who are living in Miami-Dade. So what I'm doing here is I'm saying, hey, R, make an object called filtered for residency, which has the people who live in the right place. Then I start out with a source data set, which I had imported above. And again, she doesn't need to see that. This symbol is called a pipe. This says start out with a source, pipe that data set down to this verb called select. And you can guess what select does. It selects what variables you want to include in the data set. Notice the minus. So what I'm doing is I'm saying, I don't need to analyze the timestamp when the survey was done. I don't need the record ID number. I don't need the indicator that the person consented. Then I can do some manipulations like change the secret code number 1 to be English, the secret code number 2 to be Spanish, and turn it into a categorical variable. Big picture, I want to show my collaborators the workflow, do the explanation that I just gave you so they have some idea what these verbs mean, but then Audrey and the rest of the team can look at it and tell me if I've screwed anything up. So this is subsetting down based off of residency. Then here I can subset down. I start out with what was created for the filter for residency and then filter by sex. So in this case, we want to have people who are their sex is male and their gender is male. So here you can see the comment saying I'm filtering down for gender is male. And here you can see I'm filtering down where sex is male. So again, I hope that like the verbs start to make sense. And then here you can see I start out with that filtered for gender and I'm going to filter for treatment. Why am I doing this in a bunch of different blocks? If you've published before, you know you need to have a consort diagram that says, I started out with this cohort of people, I analyzed this cohort of people, this set of people, and along the way, I lost people for different reasons. So this is coming through and making subsets of data. Wherever I've put a filter in, I'm making a new data set. And there's other variables that are processed along the way. I'm going from the first column to the last column of the data set. And whenever I get to something which I'm filtering on, I create a new data set. Okay, so moral of the story, a whole bunch of processing. The data is coming out of SPSS, so it comes with secret code numbers, and I'm converting those to meaningful words. Again, lots and lots of details. And for Audrey, she can look at this and say, yes, yes, that looks reasonable. And she'll notice wherever I put in comments. So here there's a frequency of drug use, of non-prescribed drug use. And here I put in a note to say that I've collapsed level 3 and level 4 to be more than 1 time per week. Because I think there was like a category of more than once a week and then more than once a month, whatever. Different categories with a comment so she can see that it's important. Then I take that data and I rename some things so that I can do some modeling. I put in a comment here for her to read with some, highlighting to draw her attention that this is an important point. I put in, it's not a real consort diagram, but all of those data sets that I made above, I'm filtering down into different chunks. So the residency check, some people make it, some people don't. The sex and gender, some people are needed for the analysis, others aren't. So I just go through all of the steps and I end up with an eligible set for, and then I check for missing data. Then I give her a table 1, which is showing the art group versus the prep group. So again, the 2 different medications. All of the demographics are laid out here. Sorry, I just noticed there's questions, comments in the chat. That diagram was not ggconsort. I'll come back to that. You're looking at this, and if you've ever worked in SAS or most any other language, you're probably saying to yourself, that was a pain in the that was a pain to create. You'll see just how easy it is. For this analysis, I'm using a method called CART. So CART is classification and regression trees. Well, what's that mean? CART is designed to say, I want to take all of my predictor variables and I want to come up with homogeneous, similar groups of people in terms of the outcome. Okay. So in this case, I'm modeling whether or not people are adherent to their medication request, their medication requirements. CART goes through and it says, take every single variable, put every single possible split in the data, and look and see what is the best split to make homogeneous groups of people. So put a split in the data so that on one side you have people who are highly compliant and on the other side, non-compliant. And then within those two subgroups, look and see what variables comes up with more and more compliant groups of people. So it's a machine learning method that comes up with homogeneous groups of people. So this is CART. There's some serious trickiness with CART in that it will come up with very, very small homogeneous groups of people. Your results won't replicate. Got it? So it will come up with a great prediction on a data set, but it may turn out you got the left-handed blue-eyed Baptist born in Zimbabwe, like all kinds of crazy features combined come up with one person who is perfectly compliant or two people who are perfectly compliant. So you have to mess around with the amount of complexity so that the tree, this tree is the most complex tree. And the term in machine learning is it's overfit. So it will do a great job on this sample, but it won't replicate. So with machine learning, you could go through and say, okay, I need to prune back this tree. So I can take the data set, split it into a chunk, build a tree, and look and see how it does on another subset of the data, and then repeat that process. So you start out with a very complex tree, and then you can prune it down. So again, I'm showing her this I was showing her that Audrey this so she could see this is overfit. This is too specific to the training data, but you can see some features here that are kind of interesting. So race seems to matter, whether or not the Black men are having condomless sex, not at all versus some, versus on the white and other groups. After that split, the most important predictor to come up with homogeneous groups in terms of compliance or adherence is whether or not they're using recreational drugs very often. Okay, so within different subgroups, different variables matter. But again, this is overfit. After tuning the model, shrinking it down based off of doing resamples and checking the performance, we come up with this model. And it's frankly really interesting. So we see that there's a division at the top between the Black respondents and the white and other. The white and other group is likely to be compliant. But if you go down a different path, so the Black respondents who are sexually active without using a condom and who self-report being in very good or excellent health, they are extremely compliant. So you walk your way down the path and you get different trees. That's one of the methods I'm using. Another method we're using is called Lasso, or Lasso logistic regression. So if you had a class in epidemiology, you know that there's this thing called logistic regression, and it tells you, does a predictor increase or decrease the odds of an outcome? So you can just say, does it increase or decrease the chances of being adherent? So here, I'm using another machine learning method called Logistic Lasso. And I want to draw your attention to this block. I use a dialect of R called tidy models. So like the data cleaning is tidyverse. Tidy models is the state of the art in R for machine learning. And the way it works is you say, I'm going to give you a recipe, which will say, I want to predict some outcome with some predictor. And that predictor data, that set of data may need some transformations, may need some changes. So this is completely different from those of you who've had a traditional statistics class where you start out by saying, I'm going to do ANOVA or I'm going to do regression. With the machine learning method and tidy models, you say, I'm going to do this. I want to predict this thing. And then I can have many, many, many algorithms do the prediction. So you start out by specifying the plan. And then I do, in this case, a logistic model with Lasso, and it identifies some predictors that matter. With Lasso, it's cool is things which are not relevant will drop to 0. After I fit that, I fit a traditional logistic regression model. I get some results. I have information on methods and I have information on results. Okay, so that's big picture, and I'll walk you through the details of how I did all of this magic in a couple seconds. So that's one project. Let me take you through another project. So this one is this one is submitted. So here is a different view. So this is the, I've clicked this button and I've switched into the visual editor. Okay, so that means this has text in it as well as code blocks, and the text matters. So here, these are code blocks that describe what's going on. Then here is the actual text for the paper. Then there's more code blocks. And actually, while I'm showing you this, let me knit the paper for you. Okay, so more code blocks. Oh, look, that looks like Lasso again. Oh, look, there's like a recipe floating around here again. Very similar voodoo, very similar magic. A whole lot of code, Then a description of the participants. Nested in the participants, you see little blocks of code like I showed in the first video. So here, I want to say how many people were in the original data. So I can just put a piece of R in here that says, count the number of people that were in the source data set, and it will insert that number. Then more descriptions, more text. Then there's information inserted here on like what version of R I was using, et cetera, et cetera. Okay, it finished knitting. So you will notice off the top, all of that code that I just scrolled by, the reviewers of the paper, they do not want to see that. So all of that code has been turned off, but you get the paper. Oh, notice there's a footnote. Didn't show you how to do that before, but all of the text is here. And here's another TableOne showing all of the statistics. And then down in here, there's embedded graphics. There's numbers that are here. And look at this mess. All of the betas are here and all of these numbers. For any of you who've ever written a paper and then had your clinical colleague say, I'm really sorry, person 42, they're not human. Or the study on prostate cancer, person 84, it was a woman. When that happens, you have to change every number in the paper. With this workflow, whenever the data set changes, you just push knit and it recalculates everything and inserts all of the numbers in here. You notice there's cross links that I showed in the paper. Here's another classification tree. This was predicting whether or not people would get were willing to get vaccinated. And so you see it splits on a variable like fear. You'll also notice this looks like garbage. At least on my screen, it's very blurry. So when I'm knitting to Word, it's putting a picture here, but I'm also going to save a high resolution image of it so that for submitting to the journal, I have the thing here so that when Audrey is reading the paper or we're reading the paper and proofing, we can see it, but it will look beautiful when it's published. Graphics, more cart, a reference section. That's the big picture of how I'm doing all this. Let me show you some of the gory details of how I make this stuff happen. And let me check the chat. Is there an option to have p-values along with the summary table? Great question. So in the package that I'm currently using, no. there is, it's an interesting question about whether or not p-values should be included in table 1. If there's randomization between group 1 and group 2, don't put a p-value. In this case, because I have 2 populations pulled from the population, it does make some sense to get some p-values, and there's a different package which will add on the p-values. So at the moment, I don't have them. Okay, let me go back to the slides and show you how I was doing this magic. Okay, so did I put it? Where did I put that screen? Oops. Okay. The joys of running 3 different R projects at the same time. Okay. Okay, so the example. So what I'm going to walk through today is what else R Markdown is useful for, to spend a second on that, show you some general tools for using RStudio, talk more about the R Markdown document, say more about the YAML header, the text, HTML, and code. First things first, my slides, they're done in R Markdown. Exactly the same voodoo, the same magic that I was using to write the papers, I'm using to make my slides. So there's a very, very good reason to learn R Markdown. Once you do it, you can create Word documents, PDFs, LaTeX documents, web pages, slides, books, dashboards, and websites with exactly the same syntax. And when I say exactly the same syntax, let me show you. This one. So here is my slide deck. So that slide which had that code block of what you need, here's the header or the caption at the top. Here's some bullet points and some code. Here's the summary of what I'm going to talk about. I have some numbered bullets and then some sub bullets. It's exactly the same voodoo, exactly the same magic that you use to make a paper, you can use to make slide decks. What's the difference? You just specify slightly different details up in the header. Whereas in the intro stuff I showed you, you can say output to like Word or to HTML. Here I'm saying I want to output to a weird format called the Moon Reader. All right, so let me hop back to the slides themselves. Okay. So I mentioned that the way I usually work is I start out with folded code. One thing I didn't show you, notice that this code is actually floating in its own window. It's usually sitting up here in the upper part of this window. There's a button right here which will cause the code to pop out or pop back into the document. I'm blessed to have 3 monitors, and so I will have my code popped out sitting on one monitor, and then I'll have the other features available on another. Why? It just helps to be able to see more stuff. When you're a programmer, you know, real estate is everything. So I collapse the code, I pop it out. Another thing is you can watch the word count. So again, here's the button to pop the code out of the graphical user interface or shove it back in. To do the code folding, you can go to the edit menu, folding, and collapse all. Another really cool feature is as you're writing a paper, if you have this mixture of code and text, you need a word count of the text. You do not want to have the word count of all of the code because, you know, the reviewers aren't going to see that. So do notice that on the edit menu, you can have it tell you how many words are in the body of your paper. Okay, our Markdown documents start out with a YAML header. So a header describing what this paper will be. So you've seen these details in the first video, so it is what it is. Notice that I can have output going to 2 different documents at the same time. When I knit the vaccine hesitancy paper, you'll recall a Word document popped up. Whatever output type is listed first, RStudio will pop it out and let you look at that. The other one will be rendered as well. So this is saying, okay, make the paper, put it in Word format so that we can use track changes and all the goodness you get from Word. I really like looking at web pages because I can have a table of contents sitting off to the side and flip down to whatever section I want. So the YAML header can include information on multiple kinds of outcomes, multiple kinds of output, which can render at the same time. So there's that. Another cool feature, this is for the more advanced folks, you can put parameters in the YAML header. So in a different project I'm working on, I'm analyzing either all of the data or the people who were randomized to treatment. So this is a study on addiction, and I have a lot of people who were screened, and we found out all of the drugs they were taking in the last 30 days. Not all of them were eligible, but when I'm writing a paper on addiction and I want to look at everybody who has that baseline data, I want to analyze that. But then when I'm analyzing the treatment response, I only want to analyze the people who are randomized. Okay. I could put a whole lot of like if statements in the body of my code, but that I want that controlled from one place. So up in the YAML header, I put in a parameter where I say randomization only, and I set it to true. Then down in the body of the paper, I'll check whether or not I want to run on the randomized only group, or if I want to run it on everybody. Be aware the option is there. So if you want to set like a global behavior for paper. And again, with this kind of magic, you can write a paper on one set of data, tweak a parameter, create a whole effectively identical paper on a different subset. So if you have access to, say, viral loads, and you have access to behavioral features, and you want to write two papers and parts of it are the same, here's how you do it. Same code. In the paper, in the intro, 35-minute intro, I showed you as many things that I thought you would need for processing the text of document. Didn't dawn on me to show you how to do footnotes. And then one of my colleagues asked for footnote. So it's there. If you go to the insert menu and footnote, how do you use it? You just put the cursor in the body of the text, click footnote, and it will give you a footnote where you can type in details. Didn't know that one. There you go. When I was showing you the output for the paper that's like in development, I have paragraphs that I want to draw people's attention to. So I put this little bar on the side, and it causes the text to be indented a little bit. So to do that, you can go to the format menu and say, so you put your cursor in the body of some text, go to the format menu and do block quote, and it will make the paragraph offset a little bit. It's designed for, inserting block quotes, famous sayings, but it's a nice trick for drawing attention to important sections. If you'd like to highlight a keyword, unfortunately, the point and click system doesn't support it. But if you turn off the visual editor, you can add in this little bit of text and this little bit of text, and it will highlight a word. So here I want to have the word note highlighted in yellow. So I write, this is HTML. So I write HTML, mark this as important, this text, and then stop the highlighting here. And that will cause the word to be highlighted. It's a useful trick. All right, now for some seriously cool magic. If you are, as you're working, if you want to insert something, it might be an emoji, it might be a link, it might be a picture, it might be a table. Go to the first position on a line, like all the way on the left, and type a slash. This kind of slash, not a backslash, that one. And it will pop up this interactive menu, which will walk you through how to insert different things. So if you click emoji, it'll give you a panel of emojis, and then you can click on it and it'll insert it in the paper. The image processing features are really cool. So for setting the size of an image to go in a paper, it's first rate. Down at the bottom, this is super important. So currently, the slash, you can only put it at the beginning of the line. In the daily build, so this is the prototype builds that RStudio is willing to share with the public. The next release of RStudio will let you do command slash or control slash, depending on Mac or Windows, and that functionality, you can put it anywhere. So as you're typing, if you want to insert a reference, you'll be able to do Command/ and it will pop up the tool to insert the reference. You can still use the menus, but it's pretty nice. The other really important thing to note is last week, RStudio announced that R Markdown is going to include Quattro integration. Huh? What's that mean? Limitations that are there currently in R Markdown, like trying to put in tabbed sections of an output display, and other features that are miserable to currently do, will become, frankly, simple. So the next release of RStudio is going to have major changes in the way R Markdown works, which for you as the casual user will mean a whole lot more features will be available coming soon. That was announced last week. Another trick that I learned just the other day, as you're writing, if you'd like to insert a reference to a paper, and if you happen to know the DOI, that's this crazy number thing. If you know the DOI for paper, which for me means, hey, I need to reference that thing that I published with Audrey 6 months ago. I go to Google, I search for it, I get the DOI number, and then in the body of the paper, I can type @ and then paste in the DOI, and it will show me the information on it, and it will add the reference automatically. So you don't have to go use the point and click thing. You can just do @ whatever, and it will build out your bibliography for you. Love that feature. Okay, in the body of the papers I showed you, there was some graphics, and you may have noticed that they had pretty figure captions, so light gray above the graphic. The magic for doing that is I'm inserting HTML. So I'm including web code into the paper itself. So you don't need to memorize this at all. You come back to this slide and copy and paste it. But this says, I want to insert a chunk of HTML. This is the text that will appear. And this is a tag which I can use for putting references in, and the color equals gray. So you turn off the visual editor, paste this in, turn the visual editor back on, and it'll look like this, where the caption is here with the details, and that just goes right above the plot, the code that does the plots. And then you can use this figure caption, you can use this, this tag, you can use this information in the body of the paper for putting in a hyperlink. As you do this, you'll get, you're going to want to add in more and more R. To add in R, first of all, write pretty code. How do you write pretty code? Follow the tidyverse style guide. Some people joke it's a religion, or some people comment it's a religion, as in it must look like this or you won't get hired, or you're going to get a lot of abuse from your colleagues. Live that. So click the link or go look for the tidyverse style guide, and you'll see how the RStudio community recommends you write code. Also install 2 packages, linter and styler. So you can go down like you installed Rum and add in these packages. After you've added in the linter package, the add-in menu will give you linting options. And after you've added in the styler package, it'll add in styling options. What linting is what it sounds like. It's going through and pulling out all of those little things that don't belong there. So it will notice things like if you have extra spaces at the end of a line, or if you've changed the capitalization style, it will notice things like that. It's usually quick and easy just to clean out the lint. Styler will go through and look and see whether or not your code is complying with the tidyverse style guide, and give you a set of notes, line whatever is not compliant for whatever reason. All right, don't panic when you see the slide. So when I was showing you the documents, the rendered pages, there was numbers and words that were in the body of the papers that were coming from our output. These are the functions I use to take the numeric output coming out of R and turn it into words so that I can actually have readable text. I do not want to have the number 2 in the middle of a paper. I want to have TWO. Okay. So here are functions that I use all the time. Round is what you think it is. So it will take something and it will round it to some number of digits. In the stringer package, so this is another one you'd have to install. You can install stringer, it's part of tidyverse. There's a function called string to title. So if you have a numeric value coming out of your R output and you want it to be the first word of your output, you're gonna, or a variable name. If you have a variable name and you want it to be the first letter of a sentence, you can use string to title on that variable name and it will appear as a capitalized letter. This is my favorite. So NTW, there also is, I think it is numbers TO. This is the abbreviation. There is a long version. It does what it sounds like. If you have a number and you want it to be a word in the body of your paper, you can use it. So in my inline code chunks, you will see something like this. So if I want to say how many people were in a data table, I say, okay, sum table, demographics, get the number of rows. So that would be like 14. There was 14 records in the demographics table. Convert it to words and do string to title. So that would be, it would capitalize the first letter of 12. And so I could put that in as in the body of a sentence. There's also functions for inserting p-values. So if your R output includes a p-value, which I will call a thingy, you can say, I want to show it with this degree of accuracy and add the p is less than or p is equal to feature. Oops, sorry, I should add a space there. So this will take that number and turn it into a p-value that you could put in the body of your paper. Similarly, if you have percents coming out of output, this will turn it into a percentile, show it with the tenths position with the percent symbol added on. So scales is what ggplot uses to make good looking labels. Another really useful thing is format, where scientific equals false. R likes to return things in scientific notation. You really just want to see p is less than 0.004. So it will convert it to be the decimal. A little bit more about adding results to the body of a paper. So if you have output, which looks like this, so here's my beta estimate, my confidence limits, and my p-value. You do not want this showing up in the body of your paper. You want to get like p is less than 0.001. So I start out with this. I want this. The functions that I showed you on the last page can be used to do this. Take this output and turn it into this. Yeah. So this is what you don't want to do. I do this, and then I end up changing it. So to get to this, you can embed piles and piles and piles of R code in line. I don't recommend you do that, because when you show this to your colleagues, they'll be like, huh? And it really, really is hard to parse, like, what's that comma doing there? But the way I do this now is, so here's another example from the paper, another table that I want to include values in the body of my paper. I'll put a code block and I'll do the pre-processing first. So this is take that logistic results table, this logistic results table, go to the race is equal to white and pull the estimate. So race is white, pull the estimate. So that's going to grab this number. That number will be sitting in logistic white OR. And then down here in the body, I have to move the zoom bar, sorry. In the body, maybe I won't move the zoom bar. There we go. In the body of the paper, I can reference that variable. So I pre-process. You can use all of the tricks that I showed you 2 slides back, and then you can just reference the different features here. I think that reads pretty well, and it's a great reproducible workflow. Here's similar stuff for inserting the minimum age of the sample, the maximum age of the sample. I don't want to insert this in the body of the paper, so I just put a code block here, and I can do things like scale it with the percents. You'll notice here I'm using something called Janitor. I'll come back to that in a minute. The table ones that I showed you, how do I make them? I use a package called TableOne. Why? Because it's fabulously good. It's fabulous and it's really easy. So you can just say, okay, I want to use TableOne, take the analysis data set, remove the subject ID number, and do demographics on everything. Syntax is a little bit weird. So this says do TableOne. This says use everything. So copy the slide. You'll eventually remember tilde dot, and that will produce the summary table. And it's smart. It pays attention to category. It will give you appropriate statistics for categorical or continuous variables. If you have, in this case, I've got all my predictors, but I have two levels of outcomes, or the two treatments. You say, I want to build a summary table with all variables split by the treatment variable. It's quick, it's easy. I absolutely love it. And so again, you'll notice the categorical things are showing up as percentages. The numeric things are showing up with means, minimums, maximums, standard deviations. As you're working, do notice that there's the gear sitting here by the different code blocks, and you can control whether or not the output is shown. Whether the output is shown or whether or not the code's shown. A little bit more about code blocks. Be sure to name your code blocks. Why? So in the intro video, I mentioned that there's this navigation tool down here. I think this is pretty useful. Each of my chunks, so after R, I put in a short description. So setup, tidyverse, all of the chunks are here. So you can hop to whatever code chunk you want quickly and easily. The one headache in this is the naming of these chunks needs to use shish kebab case. So you know about uppercase and lowercase. Some of you may have heard of camel case and snake case. This is shish kebab case, words separated by dashes. To help you with that, here is some more work from Alison Horst. So kebab case versus snake case, which has the underscores. So remember, the captions, the code blocks need to be written in kebab case. Tell you about a couple functions or packages I use all the time. TableOne I've mentioned, Skimmer, Janitor, and Diagrammer. Skimmer is just the best as you're trying to discover data. So down in the console, you can make it kind of wide and then say, use the Skimmer package, the skim function, and then give the name of a data set, and it gives you a lovely summary of the variables. The categorical variables, you see number missing, you see the number of people in each category. The continuous variable, it gives you this super cool little pseudo histogram. So you can see is like the data bimodal or is it all skewed, along with the descriptive statistics. So when you look at my code, you'll see Skimmer everywhere as I'm working through the data, finding problems. I use Janitor to make frequency counts. So in regular old R, a lot of people just use table. Janitor has a slightly different, has a creative spelling of table. And so you can say, hey, Janitor, do table on this variable, and it will give you a table that looks like this. And then you can filter it down. So here I only want the yes people. I want to pull the percentage, and I want that to appear as a percentage with 1 decimal place. So here's that scale stuff I mentioned earlier. So here I'm making insurance. It says include insurance, and it looks like this. Love this package and this workflow. Diagrams. So last week was the International R Medicine Conference, and they rolled out a completely reworked version of GG Consort. So I haven't tested it yet. For now, the way that I make my consort diagrams and my flowcharts is I use Diagrammer. So early on, I walked through and I talked about filtering and making different subsets of data. Then I want to plug those into a diagram. This is the Diagrammer syntax. It's pretty horrible, and it's pretty hard to do right. But if you copy this and paste it, you'll be okay. The idea is you say, I have different nodes. Some are capital, some are lowercase, just because that was what made sense to me that day. And then I have nodes, so connect node A to node B. So A to B and A to capital B. So you specify the connections, and then down below you specify the labels. So the A node will be labeled with 1, and here is what goes into that. This is pretty awful. I'm hoping that GG Consort will be better, but it is very functional, and after you've done it once, it's not so bad. I already mentioned a bunch about modeling in the early stages. Just want to quickly run through some things to have in your head. So tidyverse is the way that most people process our data now. Tidy Models is the new ecosystem for doing modeling, especially for machine learning. There's a set of packages, just like there's a set of packages in tidyverse, that do different tasks. So pulling out subsets, specifying a model, doing the actual recipe for pre-processing the data, building a workflow to link things together, tuning to come up with like, what was the right amount of penalty to put in that cart tree, and yardstick for getting information back on the quality of your models. And then Broom for taking chaotic looking text out or inconsistent looking text output from our modeling, and having it always come back into a table like these tables I was showing you here. So this is after Broom has processed a model. Rather than having some crazy text, you actually get a table. Okay, so why bother? After a little bit of getting used to it, it's just easier. So here's the general way it works. You can specify how to pre-process your data, split it into 2 different sets for building models and verifying. You build a recipe again where you say, I want to predict this with stuff. You can put in rules for how to process the data. And then this is going to make a data set. There's that skim thing I mentioned. And then after I said, I'm going to do a prediction, I can say, in this case, I want the prediction to use logistic regression, then some gory details for doing lasso. I pull out information on how good the model did. And after I fit a model, I can then say, okay, now I want to apply it to another data set to look and see how good my prediction performs on a brand new data set. And I can get metrics on how it does on the new data. That's a lot. If you'd like to learn more, I'm hoping that to be teaching a new class in January. We're setting up some details and ironing out the paperwork, but hopefully there will be BST 626 maybe, which will be applied statistical programming in R coming in January. If you're at I will certainly be teaching machine learning for health research. So that's what I just spent 2 minutes on across the summer. All right, that was a lot. Deep breath. I know I would greatly appreciate if you could take a moment to fill out the survey that Rosanna just put in the chat. And I'm more than willing to take questions, comments, complaints. I've never taught this before. So other than, oh, that was fast, anything else I should be thinking about? Unmute yourself and say things.
Just want to reiterate to please take the satisfaction survey in the chat. Thank you, Ray.
That was awesome, Ray.
So I'm seeing some thank yous. How about some questions and comments before I?
So I have a question, Ray. It's sort of a broader picture. It sort of steps back from this. One of the things I thought about as you were presenting this is you have the paper and all the analysis together. And you can write your paper to, say, Word format. I know that. And your collaborators are going to want to look at Word and edit it. How do you deal with going back and forth between track changes in words and your R Markdown?
That is currently the weakest link. At the moment, I take, prepare something in R Markdown, hand it to Audrey, hand it to the rest of the team. They give me feedback in track changes, and then I will edit the document on my end to match what they had asked for. It is definitely the weakest link. The right way to do this, and I've only been doing this hardcore for I don't know, 6 months, a year. The right way is for my colleagues to start to use the visual editor as well. So in the intro version, in the intro video, I hope I convinced people everything that you do in Word is there. And so if everybody is working on the same document with an R, using a tool like GitHub, all of the track changes get built into the workflow. But right on, it's a great question. I will come up with better workflows, but currently I export to Word, colleagues mark it up, and then I go back and I change it in the raw document, in the R Markdown document.
Okay, so then I have another one that again is sort of expansive, so it's not a specific question, but you've shown how we can take and have a self-contained replicable workflow for a paper, but it's sort of assuming that the data is perfect from the start.
Yep.
So I would imagine there's an extension of this process for the workflow to make a project.
So right on, great question. Great, really big question. So traditionally in R, people would write R scripts. And so you would end up with a folder that would have 2 to 1,000 .r files to do different tasks. These days, everything goes, well, the modern workflow is to have an R project where there is a folder. In that folder is a subfolder called capital R, which contains scripts for things like functions. And there's another folder floating around called inst. And usually in the inst folder, you put in all of the pre-processing code. So, and I should probably teach that, but there's conventions for where to put different stuff.
Right.
There is nothing that says you cannot have a code block at the beginning of this document, which has 20,000 lines of data cleaning code. Okay.
Right.
But the general wisdom, the general consensus is if you have a task which is run rarely and is time consuming, pull that out, put it in a .r file, and then call it once call it and save files, or call that .r file within your R Markdown file. So that instead of having literally 20,000 lines of data cleaning, you put that in its own file, and then you just say source cleaning.r. There's
right.
lots
and then you have a separate sort of documentation structure for that whole process. Yeah.
Absolutely.
Okay.
If you do put it all in one R Markdown file, there is the ability to say, automatically pull all of the code chunks out and turn that into one .r file. So that option is available also. There's a whole lot of interesting computer sciencey type, whole lot of conversations going on with the people who focus more on data science than on stats about what's the right way to organize these documents. So where should the code chunks go? Personally, I put my analysis code chunks way up at the top of the program, but then like the data cleaning things for getting the numbers ready for a paragraph, I'll put a code block right above the paragraph to change the formatting. There's some great conversations going on to come up with best practices for that.
Okay. Thanks.
Thank you. What else? Questions, comments, complaints? I'm going to try and record this for the world, and I'd much rather get questions from you guys than from 50,000 confused people from around the world.
Those files, the Git that stops it from being public, and the other one in the presentation, I think it's the Gitnor.
Yep, Git ignore.
Does that all get created when you make a new folder with the new project, or how do you set up all this stuff for the new project?
Great question. If you use the rum package, it will pull in my current git ignore file. So I actively always going through my gitignore and adding on new files. So I recently added on SPSS file formats to that. So if you use rum, it will go out and get my latest gitignore and put it into the folder, into the project folder. If that's one. If you create a project on GitHub and then you clone it, if you pull it, copy to your local machine, RStudio will put in a really wimpy gitignore file. You want to either replace that little, literally 4-line gitignore file. You can copy my rum gitignore, and that's covered in the intro video. The other thing is you can also just go on the web and find my gitignore. Let me show you. And this is something I will be changing when I re-record the intro, or I'm going to add on another section to the intro. If only I could find, okay. So here, if I go to GitHub, github.com, me, it will look a lot like this for you. Right here is a link to my gitignore. So if you have a project and it has a gitignore, if it has the little 4-line gitignore and you want to use mine, you can click on this link and then click on raw and then copy this and paste it into the gitignore file. And you'll see, for those of you who work with other languages, if you see a suffix here that I should add, please let me know. But you can see I've tried to capture all of the ways people save R data sets, the different spellings or capitalizations of CSV, SAS data sets, et cetera, et cetera. So that's
maybe
one way
the export.
Correct.
The export. But so you're saying if I start a new project, I shouldn't start it from the can't think of the name, RStudio. Like I don't, like, let's say I wanted to start a new project. So I say new folder, and then I'm going to copy your gitignore. And what about the other one that keeps it private? I'd have to copy that one too, and then start the RMD file.
So
start a new file as a R Markdown in that folder.
So the workflow I'd recommend is install rum and then go to the, let me just show you, it's easier than talking. So here, you can just go file, new project, new directory, and come down here to research project template.
Oh, okay, right. Yeah, you had mentioned that. Okay.
And so that will make the project, it'll give you an RMD file.
Okay.
And it will give you a gitignore file and some other goodies. So that would be one workflow. The other workflow is you go out to GitHub and you create a project. And then you would go back here and you'd say, create a project from version control from Git, and you'd put in the URL here from the intro video. Then after you've done that, replace the gitignore file that RStudio creates for you with mine. Because again, if you pull a copy out of GitHub, RStudio will put in a little wimpy gitignore, which will allow you to sync your data sets with GitHub on accident easily. So that's the workflow I'd recommend. That said, the University of Miami is, I'm asking a lot, but I'm aggressively asking UMIT to build out an alternative to GitHub called GitLab. And so GitLab will allow us to sync our protected health information, but it's not in place yet at University of Miami.
Okay.
Ray,
Great question.
Ray, I put this in the chat, but would you mind creating one of those workflow images for your recommended workflow, pretty much just giving a visual of what you just described?
Yeah, so I will add that in. I will record it. And so I'm gonna record everything what I just went through. I'll record it again, clean it up, and I'll put in a section on that. Thank you. That's a great thought. What else you guys got? Anything else in the chat I need to be looking at? I don't see anything else. So thank you all very much for joining me. Look me up if you have questions, comments, or complaints. I'd love to get feedback. I don't see very many presentations like this on the web, so I want to clean it up and get it out there for the world. So if you think, after thinking about it, if there's something that comes to mind, please let me know, and I will add in some more stuff.
Thanks, Ray. Good talk.
Thank you so much, Ray, and thank you everyone for joining.
Bye, everybody.
Thank you. Bye.